On behalf of the United States Merchant Marine Academy, our Committee on Community Affairs, I want to welcome everyone to the April offering of the Kings Point Industrial Hour. My name is Michael Rolls. I'm a professor of marine engineering at USMMA, and I'm a member of the committee. I will be moderating this hour. We ask that you keep yourself on mute and submit any questions or comments you may have to the chat panel. I will be monitoring the chat and monitor them accordingly. We are fortunate here today to have with us Kings Point class of 2000 alum, Edward Schwarz. Ed is the Vice President of Marine Systems at ABB Marine and Ports. Today, he's going to be sharing with us his musings regarding the subject of carbon neutral shipping. Ed is responsible for ABB's marine systems business in the Americas. He has a deep passion for bringing new green technologies to the maritime industry. His proudest project is the first all-electric zero-emission vessels for the Maid of the Mist Corporation. Ed is a graduate of the USMMA, Kings Point, and former Unlimited MEBA chief engineer. Previously, prior to joining ABB in 2017, he worked for Voith Turbo and ZF Marine. Ed is also the president of the USMMA Alumni Association for South Cantle, Pennsylvania. Please stay with us after this presentation for a Q&A session with Ed, as well as ask for your participation in a short poll about the Kings Point Industrial Hour. We ask that anyone willing to provide additional input to the committee, please reach out to me with your contact information. I'm going to repost my contact information into the chat room. And at this point, I'd like to welcome Ed. Thank you for joining us, Ed.
Wonderful, thanks, Mike. Yeah, it's quite my pleasure to address everybody on this topic. It's something we've been talking a lot about the last few years. So it's very interesting to us, and appreciate the opportunity. And hopefully, it's interesting to the midshipmen at Kings Point, and I think it will be. So what I'm going to be talking about is some of the technical challenges in meeting these new decarbonization requirements. We see a lot of talk of sustainability within our industry. Kind of looking at what does that mean? How does that influence vessel design in the future? What does that mean for Jones Act vessels? How is that going to impact alumni as they're going out into the industry? There's a lot of changes coming, so I'd just like to talk briefly about them, and then we can get into some questions and answers and share some projects that people may not be aware that are ongoing right now. So if we look to this carbon-free shipping path that we're on, this transition from carbon-based fuels to zero-emission fuels, it's not an easy path. And I think you've probably I think there was already some presenters that talked about different fuel types and the path to zero emission. And what we're seeing is it's really kind of a technology-heavy driven enterprise to do this. And there's really not going to be one fuel, one method of decarbonizing transportation, but we're going to see a lot of stratifying of the industry into these different modes of zero emission technology that benefit to bring that goal, that ultimate goal that IMO has set for a 2040 carbon-free shipping, or at least carbon neutral goal. And then we see some of these shippers like Amazon and Walmart calling for reduced emissions in the supply chain. So we're on this path. If we look from left to right on this chart, you can see of these alternative fuels that are being used, whether it be methanol, ammonia. We're looking at reforming on board to create hydrogen and then utilize that hydrogen. There's also a path of creating green fuels, so these green ammonias, green hydrogen. All this is being developed. This is kind of development of green fuels is kind of new, but we're working towards it. And if we look at what's available today on the bottom left side of the chart, you can see we have the short connection, short charging. This is pretty much an established way of decarbonizing ports with cold ironing. A lot of vessels are already using it. We're going to see more and more requirements to cold ironing vessels when they come in, but it also comes with some challenges. We're seeing now the utilization of batteries on board. Designing with batteries is becoming more and more frequent, and now we're seeing kind of the more modern introduction of fuel cells, and then eventually some more larger fuel cell scaling, because right now the available fuel cells are kind of small, but we're going to start to see them scaling up, and then we can get towards towards this ultimate goal of complete decarbonization. If we look at the technology, so how's the technology bringing this decarbonization options to the maritime industry? We see this path. So we're familiar, we always kind of use a mechanical propulsion system as a baseline. So this is something we designed to today, very familiar. It's diesel engines, usually either direct, if it's a slow speed diesel, it could be direct propeller speed, or it could be going through a gearbox into a propeller system of some type. And then you also have separate generators on board for creating ship power, electricity on board for electrical consumers. So this is the standard design. It's been around since we moved away from steam engines, with a process to move away from steam engines to diesel engines. This is pretty standard as being the historic kind of baseline to design. Not new is these electric systems. They've been around for over 100 years now, but they're being utilized from different vessel segments now that traditionally were not looking to diesel electric, are looking to diesel electric. So diesel electric is, again, having diesel engines on board, but now you're creating electricity, and then that becomes the backbone of distribution through the vessel. So your propulsion motors are run by electricity, and then also your ship's power is usually utilizing the same grid. This can be an AC system or DC system. So what's old is new. So we're seeing DC was the original power source on boats. Now AC is obviously very popular, but now we're seeing a trend to go back to DC powers as we're looking at introducing energy storage or fuel cells that produce in DC. So we have these electric, very common for oil and gas industry. OSVs are all built kind of diesel electric style for efficiency. All the cruise industry, cruise vessels are built for diesel electric. Oil and gas, offshore drill ships, diesel electric. So where you have a large house power demand, diesel electric has historically made sense. Now, if we look into the more modern, where things are going, and we say kind of like it's becoming the standard, the modern standard, and it's reaching commercial maturity, is now looking at this hybrid electric design. So a hybrid means having multiple power sources. Obviously, if one of the power sources could be diesel generators, and then the other power source could be batteries or a fuel cell. And we're looking at kind of optimizing the profile, balancing the system in order to provide part of the operation under zero emission. So this could be, for example, we go back to those OSVs. A lot of the OSVs are now being retrofitted with containerized battery solutions so that they can provide zero emission standby time when they're working on the rigs. So that's becoming a requirement of the oil companies. So we're looking at saying, okay, when you have these either low demand periods, or if we can reduce the amount of engines running with batteries, we want to try to find these types of gains. And now what we're looking at is kind of this progression to zero emission, which is going to be, instead of the diesel engines, you have fuel cells, and then you also have a battery. Most fuel cell designs have batteries, is kind of what we see in design, and mostly on the smaller vessel size. Larger vessels, maybe there's a lot of experimenting going on with alternative fuels for methanol engines or for ammonia engines. So there still may be engines, or there will be engines in future designs. They just may run on alternative fuels, and then therefore, if the power density is not there in that fuel type, then it still may be an electric driven application where you have batteries to help with some of the load requirements of engines and holding them at, either being able to utilize variable speed engines or holding engines at a optimum speed. But we see this is kind of more and more designs. If we look at kind of what's interesting right now, I think that just went out for quoting is Scripps is building or presented a design for a hydrogen fuel cell research vessel. So we're seeing more and more of these projects coming out where people are trying to look into these alternative fuels for zero emission applications. What's interesting to us and should be interesting to marine engineers is the fact that in all these types opposed, except for the first diesel mechanical option, is now we're seeing electric propulsion kind of becoming the backbone of these designs. There's a lot of advantages of electric propulsion. It gives a lot of flexibility in design. It gives the ability to integrate these different power sources. So here you see you can have electric motors driving things, which can be more efficient. You can introduce energy storage. Later, we can introduce fuel cells. And it also lends itself to providing this shore connection, shore power, which is the ultimate gain in a lot of the short distance shipping, is moving to the utility power to reduce emissions. So what we're seeing is a lot more electrical engineering. So we're seeing this kind of shift. And what's interesting maybe to the students is we're seeing a shift of mechanical systems to electrical systems. And these are, albeit kind of complex, I'll say, electrical systems that require a lot of automation. There's a lot more design that goes into these systems than say a typical shaft line system would. So it creates a lot more challenges in the design, but also creates the opportunities for different types of work and different types of designs. So that's what's really kind of interesting, what's going on in the market right now. What I'd like to do, I think. Okay. Sorry about that. Screen froze up. So I'd like to highlight, I think always what's interesting is to highlight actual vessels. And we can look at their design a little bit and look at some of the challenges of these vessels, and then kind of inspire some thought, and we can see the scalability of some of these things. So I picked four projects that we were involved in. And it kind of, one's in San Diego, one's in the New Orleans area, one's in Seattle, and one's in upstate New York. So kind of four corners of the US. We have these four projects, completely different vessel types, utilizing different technologies that are looking to go zero emission. So Crowley's constructing right now an all battery hybrid tug to work in San Diego. We've worked on a few hybrid tugs. This one's really interesting, the fact that the bulk of the power will be delivered by batteries. So it's not just for batteries for light use. It's really intended to have batteries for its operating profile. Next one I'll talk about is Maritime Partners Hydrogen One project. So this is a methanol hydrogen very low emission towboat that's looking to operate in the New Orleans or Texas area. Next one is Washington State Ferry. So Washington State is decided to convert all their vessels to battery electric. So we're involved in designing and building the first new build all battery ferries. And lastly, here's Made of the Mist vessels operating up in Niagara Falls that run on all battery, no engines on board. So a unique project like that. So I guess we'll talk about Made of the Mist. It's an interesting project. So this is a project with no engine. So it's complete battery operation, including emergency power requirements. So there's no diesels at all on board. One of the things that was interesting about this project, or a challenge of it, was it wasn't governed by any of the Coast Guard CFRs. There's no CFRs for a lithium-ion propulsion, solely lithium-ion propulsion battery vessel. So we had to work very closely with the Coast Guard. It's very enjoyable working with the Coast Guard to help kind of design some of these, help them to update the rules and create these new processes for safety for these new technologies. It had there's two vessels up there. And what they do is they run a tour around the falls, and they have this 20 minutes that they unload passengers and load passengers. So you kind of have a short period of time, this 20 minutes to charge. If you see Teslas and a lot of electric vehicles right now, it's difficult to charge quickly. So here we're charging a rather large, vessel battery size in a very relatively short period of time. And then also what's interesting is that the vessels lay up in the wintertime, which creates some special challenges in the design to have a completely dormant cold boat. A lot of this new technology has very special requirements around temperature. that have to be taken into consideration. So these vessels are up and running, quite successful. I encourage anyone who can get to Niagara and has $20 to take the tour. It really is something special to be on a vessel that has no vibration, no noise, no emissions. You can see the top deck completely open with no stacks. So it's definitely a different experience. But some of the lessons that we learned were how to maximize that off-peak charging. So when we get into utility power, you'll realize that there's a lot of requirements that come from the utility provider when you're hitting the utility. It's really quite amazing electrical power in the fact that you can go to your house, flip on your light switch, and there's enough power there, and then you flip off your light switch, and you don't need that power, and it's absorbed by the rest of the block. It's a really tough task that utilities have to balance this demand. So as vessels are looking to utilize the utilities more, it definitely demonstrates some significant challenges. How to design redundancy with energy storage. So again, not having those default emergency diesels. It's typically in designs where you just kind of default to having emergency diesels running when you need them. They come on and just run and supply power. It's how to do that, but without the diesels, but do it with the energy storage. Work with Coast Guard and MSC on this new technology. So I can tell you that anybody who's doing design work, who's operating or building vessels in the United States will work closely with Coast Guard. And it's really great to work with them. The other one was, dealing with this extreme weather. It's obviously gets very cold up in the Buffalo area in the wintertime. So a unique project. It was fun to work on, and it was nice that this project's in the U.S. That it was one of the first vessels globally to have no engines on board. Because even though you'll hear a lot about the Scandinavian ferries that are all moving to battery, but they still keep engines on board for backup, which makes for challenges that this owner wanted to avoid. Talk about the Crowley E-Wolf. That's what they're calling their all battery tug. So some of the challenges in the design we can talk about is that, you can see it's a tug. So this is a significant amount of energy storage. So I think it settled about 6.2 megawatts of power. So that's a lot of battery power. If you're not familiar, 6.2 megawatts, and to fit that into a tug design, where tugs are some of the hardest vessels to design for because of the space restraints, was very challenging. So you can see the cutaway drawing there, fitting a lot of batteries, a lot of electrical switchboards into a small space. So it really challenged us in adapting maritime design for smaller vessels, which is really going to be rewarding as we're seeing a lot of these smaller vessels move to these zero emission solutions. So CARB, I don't know if people are familiar, but CARB is a California Air Research Board. They're involved in these projects, and CARB has announced its new requirements that are going to require that any vessel that has a less than 3 nautical mile transit, passenger vessel that has less than 3 nautical miles, has to be zero emission to operate within the boundaries of California. So this is, and I think it's 2025. So very quick, very lofty ambition that CARB has and requirement, but the technology exists, and the industry will find a way. But what is significant about it is obviously this won't be only to California. We obviously will start to see this migrate to New York, to Washington State, Oregon, other states. We even see Texas moving to a lot of zero emission ports requirements. So this is definitely, maybe California may be the first to do it, but the trend then kind of flows through the rest of the United States. So we're going to see a push for more and more of these zero emission ports. It's going to first start with passenger vessels, but then we'll work towards these types of working vessels. So harbor craft. So the vessel's under construction right now. What are we learning? And also to let everybody know, we're executing these projects out of our Houston office. So we're working closely in the US. One of the few companies that are kind of have this knowledge base in the United States. Most of the companies that do this type of work are doing it from Europe, either from Europe or Scandinavia, and we're trying to do this in the United States. So we work closely with the U.S. Coast Guard, like I talked about. There's a lot of detailed engineering to ensure that we don't have many changes to the vessel, because the vessel is under construction as we're doing design. So anyone who's a systems engineer can imagine it is difficult to work with kind of predetermined spaces and having to make the equipment fit into the spaces and the volume you have, rather than making the space fit to the equipment. I would say anyone who's looking at this is also not to underestimate the shore charging challenges. So if we look at this design of this boat, you can see there's a lot of energy storage, a lot of batteries, and very small emergency diesels. So these emergency diesels are basically just kind of a go home feature. Not enough power. It's not going to generate enough power to charge those batteries up to 100% and then operate the vessel. So we're really going to be reliant on shore charging. And as soon as we have this interface between the vessel and shore power, it creates a lot of challenges. So you see a lot more engineering now on shore side work. It's not just the vessel, but it's also really understanding shore power, civil engineering, these types of things you see in the maritime industry kind of growing into the ports side of things. And then startup and commissioning plans are critical for these types of vessels, because it's a lot of new technology for an owner, for who's going to operate. There's going to be a chief engineer on board who's probably very familiar with diesel engines, but won't know much about these types of systems. So we need to make sure we have the training for people and the processes and deliver a vessel that's fully functioning. Some goals on the delivery. So it's a Q1 2023 delivery is the goal. So hopefully you'll start to see some announcements. Anyone who's following the trades within the industry will see certain conversations about the vessel. I also, if anyone wants to contact me, is in the San Diego area in the next year and wants to take a look at the vessel, I'm sure we can arrange something with Crowley. Crowley's obviously a great partner for projects like this and a great operator in the U.S. Talk about the Washington State Ferry. So this is a large battery operation. So this is over 10 megawatt hours of battery, which will put it at the largest installed battery operated vessel in the world. So again, we're seeing some of this trend. The Crowley, the Maid of the Mist was a first in the world of its kind. We're seeing that the Crowley vessel is a first of its kind. And we're seeing the Washington State globally will be a first of its kind. So we're seeing this kind of trend in these new green technologies is allowing the US to take a leading role globally in some of these new technologies, which is very exciting. So yeah, 10 plus megawatt hours of battery power. Short charging interfaces. So this is obviously high voltage charging. And they have a whole fleet of vessels that they want to make sure that they have standardization requirements between the fleets. So that creates some challenges in the design to have commonality. What we've learned so far is, working again with the Coast Guard in getting everything approved prior to construction, a little different than the Crowley project. These are interesting projects where anyone who's looking into naval architecture or design and construction, maybe the shipyard management students, is now we're seeing a trend in the market to move to these SSVs, they call them single source vendors, because the systems are getting so complex and there's a lot of very specialized knowledge. What owners are looking for is one company to supply all the way from the bridge to propeller and guarantee an integrated system. So typically, if you were to build say a ferry of a diesel mechanical, the owner would go to the shipyard and just say, hey, provide me a ferry that can do this and meet the Coast Guard requirements. And maybe they have a preference on an engine type. But the shipyard would be responsible for making sure that the engine and the shaft line and the gearbox and the propeller were all integrated and very skilled at that. Shipyards have a lot of experience with that. But when it comes to this new type of technology that's highly automated, very technical, high in the electrical engineering side. We're seeing that the shipyards currently don't have that skill in-house, and they're looking for suppliers to really take on that full responsibility and that full integration. So it's kind of creating these new roles within design, ship design, and ship construction of the SSV. And then one of the last topics that we're, as a lesson learned, is there's obviously a lot of technology risk in these first projects. So we're seeing these big companies, whether Washington State Ferries is one of the largest ferry operators in the world, or Crowley, a very large maritime company, being the first to take some risk on these new technologies. But in order for this to really work long-term and to be adapted to a standard, we got to figure out how to cost this technology risk, is another big part of it. So there's this costing side that I'm sure people are taking classes on now. Is that the finance side of engineering is also very important. So it's kind of balancing both the technology and the finance. And then I have a picture there just kind of show the utility integration. There's a lot of work shoreside. So it's like I said, you see the maritime industry kind of going into being really a port facilitator, not just the vessel side. So ports are kind of maybe very simple, docks, and having access, and okay, if it's a container port, you have a lot of crane facilities and operations. But now we're looking at them really being part of the vessel by supplying the power, having this high voltage ship to shore connection element. So it's definitely, and I can tell you from my perspective, the port side is a lot more complicated than the vessel side. The vessel side engineering is a little less challenging. So really, we probably spend more time talking about the design of the vessel, of the port side, than we do the vessel side. So it's also kind of a transition and shift in marine engineering. And I believe this is the last one, is to talk about the hydrogen one. So this is a very interesting towboat that's under development. So this is a really, really first of its kind. So this is a towboat that pushes barges, and the desire is to have it as methanol as the fuel. So what we're looking at doing is how do we get hydrogen on board? And we're looking at using methanol to convert the methanol to hydrogen on board, and use a reformer to do that. So this is really advanced, really interesting things going on here with this project, is to figure out how to do that. Once the hydrogen is created, okay, then we have the fuel cell, which is also very interesting. But then coming out of the fuel cells, you have electricity, which gets us into something that we're much more established, much more familiar with. But it's introducing to the maritime industry definitely all these new challenges. Reforming technology, which is a new. It's not new to other industries, but it's definitely new to the marine industry. Fuel cells is very, very new. So you see more of this kind of chemistry, more of this chemical chemistry type of understanding that's different than just the typical fuels on board that marine engineers are kind of used to today. So, and the other challenge with this is the reason why. I mean, I'm sure there's plenty of books written about civilization, the discovery of carbon-based fuels, and how great that is, and how it moved things along. And it's so true that we will not find another fuel as easy to use as a carbon fuel has been for us. So these other fuels come with a lot more challenges. They're much more volatile. They could be very dangerous. Right now, diesel fuel is relatively harmless to humans. It's bad to the environment, but it's relatively harmless to humans. It doesn't require a lot of special consideration and storage, and yet it packs a tremendous amount of energy density. We're not going to see these with these new fuels, so it's going to introduce a lot different challenges of storing, of moving chemicals, of moving these alternative fuels on board the vessel, consuming them, releasing them. It's definitely going to be more of a challenge, but that's the direction we're going. So some of the things with this was how do we make this scalable? So obviously this is a small vessel. The goal is to make this more scalable, and larger fuel cells to utilize for larger vessels is definitely the future. And then also, we don't think that methanol will probably be the best fuel for every application, but there's certain areas of the US where we do have methanol available, and it is in excess that can be used to then create the hydrogen that we need on board. Some of the lessons so far is, as I'm sure your teachers tell you, it's in the details. Integration is all about the details. You can't just assume things are going to work out. You have to kind of really get into the details to find out where the challenges are and to prepare yourself for them so that the project will work. Understanding operational profile of vessels. So this is also very interesting. When we come to this, any of this new sustainability is really kind of understanding how vessels operate. We're really looking at optimizing vessel operations. Probably the first step towards reducing emissions is really understanding when you need power, how much power do you really need. Currently, the maritime industry is pretty much based on engine sizes that are available to the marine industry. So the marine industry either develops our own slow speed diesels, or we use engines coming from other applications, and then we design vessels around this installed power, and then that becomes the power of the vessel, power requirements of the vessel. This whole movement is to kind of move away from that nameplating of power just by installed power, but really trying to figure out what is the actual power requirements to do a job. And it's actually a lot harder, and there's a lot of sub-industries within the maritime industries working on this. And then again, Coast Guard, it's been a common theme, but to work with the Coast Guard to establish some rules and ways to work with this new technology is always part of the projects. So in closing, as I was preparing this, I was kind of thinking, why is this important to midshipmen at Kings Point? And what I could say is that if I was to take away one thing, if I was in your shoes, it would be, it's probably never been a better time to hit the industry as a marine engineer. With all this technology coming, it's very exciting, and it's going to create a lot of different niches that currently don't exist. I would say the maritime industry is pretty homogeneous, but now it's going to change. We're going to see a lot of new technologies, a lot of different parts of the maritime industry that are going to open up. That'll give you a lot more opportunities, different opportunities than were available before. So if we look at these disruptive change, what does it create? These opportunities. We're concentrating on U.S. Jones Act vessels in this conversation. Most of those vessels are short distance shipping in the United States. I know as cadets, you go out and spend a lot of time on container ships and ro-ros and these types of vessels, but the vast majority of vessels in the Jones Act fleet are in the short distance shipping, which traditionally were relatively cheap vessels and kind of simple designs. So we're not maybe very interesting or didn't need a lot of support, but that's going to be changing. And we're really seeing that the short distance shipping segment is the one that's adopting these disruptive technologies the quickest. So it's very interesting that it's opening up maybe markets for Kings Pointers into these short distance shipping, either operators, design firms, shipyards that maybe before would not have needed degreed engineers or licensed engineers, but now we're seeing that these vessels are becoming more complicated. They're definitely more technical to operate and to design. So it's kind of opening up new markets. If we look at systems technology, marine systems technology, it hasn't really evolved that much over recent decades. If I think about myself, when I graduated from Kings Point, I upgraded my steam license before my diesel license, not by choice, but just because I was catching a lot of steamships coming out of the shipping out of the MEBA Union Hall. And so when you look at these vessels, I was on older vessels, there's a lot of older vessels out there. We're seeing this really kind of big shift. So if you looked at a vessel that was built in maybe 1985 and you built a new vessel in 2025, there may not be really that many changes if you look at the actual design of the vessel. Little changes here, efficiency gains, absolutely. a lot with the navigation, but really the kind of the plant is really kind of the same. But that's not going to be the same for the next 10 years. We're looking at this really extreme transitional phase in the industry over the next 10 years. Everyone's kind of who's graduating over the next few years is really kind of entering a very interesting part of the market. And you're given the opportunity to kind of be part of this transition. So when I think of myself of having started my career on steamships to what I'm doing now and helping to design and deliver, say, for example, hydrogen operated vessels, it's a big shift, and you guys are going to be coming right into the right time to be part of that. So it's a great time to kind of hit the market. If you're interested in a lot of different things, it's going to present opportunities. Next one was electric propulsion. I talked about making that easier to implement these new technologies is electric propulsion, but that also opens up digital. And what I didn't talk too much about, but we're working also is these augmented automated systems and eventually kind of autonomous remote operated systems. If we look at what SpaceX and Blue Origin are doing, they're providing vessels that have no operator on board to catch these rockets. So a lot of the technology is developing now that's going to lead towards this remote operations and augmented opportunities. So for the captains and mates, it's going to be a period of working with augmented systems. We see that even in our cars as our cars now have lane detection and auto braking and these types of safety features. We're going to start seeing that also kind of come to the vessels. The Crowley tugboat that I talked about earlier has is going to have our augmented automation system to help captains be able to do more while on the bridge. So you're going to start to see the quote unquote, self-driving vessels are going to be developing and being released. So this is interesting. And then with that connectivity is going to be more of a port's role in the marine industry. So you're going to see more ports, like I talked about on the electrification. Ports is definitely a big part of it. And then we're going to see, this kind of automated remote operating vessels, auto docking vessels, these types of things, which is going to give a stronger connection to the ports in which we operate, which will develop new opportunities for the industry shoreside. So it's not just the vessel side, but shoreside, we're going to start to see more and more opportunities as the work gets shifted from the vessel side to the shore side. And then lastly, I would definitely see shortages in many industries, but the maritime industry definitely is one of them. Everyone is bemoaning the lack of qualified engineers and mates. And we see this new technology is going to allow for more diversity. So it's different skill sets that are needed. It's not just the deck plate engineer who starts by working on a diesel engine and then works their way up. It's really going to take a lot of different types of technology. So with that, the maritime industry is going to have to look for diversity. So everyone is diversity is kind of the buzzword right now, but it definitely is a good thing. I think one of the things that's prevented the maritime industry from making a lot of these changes sooner is the lack of diversity, because it just has a lack of diverse thought within the industry. If everyone has the same background, if everyone comes from the same life experiences into the industry, then obviously you get the same way of thinking that then prevents these new ideas. So we're seeing this kind of shift to allowing for more diversity, and then more diverse skill sets are going to be needed. So that's also going to allow for different careers. So as sustainable solutions are going to need more electrical engineers, more automation engineers, more programmers, these types of things. It's not just going to be turning wrenches on board a vessel or steering at the helm of the vessel. It's definitely going to be a different developing industry. It's going to create more opportunities. So if your instinct wasn't to just be a onboard engineer, but you find interest in automation and programming and these types of things, the maritime industry has a desperate need for that in the future. So we see that as being kind of very important to young students right now, to realize that there's an industry for a lot of different types of skill sets. And that's all I had, and I think I'm right at time here. So I turn it back to you, Mike, if you had some questions and answer, but I appreciate the opportunity to talk on some of these new technologies, and I'm available if anyone has any questions, even offline. I believe my information's out there, but you feel free to reach out to me, and I always appreciate the opportunity to support people.
Yeah, I'll repost your information out to the group here. I appreciate it, Ed. That was an excellent presentation. Gave me a lot of inspiration on things that I can do for the students here about tailoring some of our projects towards getting them to get interested and curious about this stuff. That's something our faculty here are always interested in doing, is what can we do to inspire hunger in a subject. And,
Yeah.
you kind of answered the question, the third question that came up, which was about the skills enhancements and stuff like that. But the answer was more tailored towards the, well, dare I say, high school or plebe. But someone who's getting ready to graduate here with a marine engineering degree, they're kind of already baked into a certain skill set.
Mhm.
What can they do to make themselves more successful, better chance of success after the fact? Like Shelby getting ready to head out the door there. She's got a degree pretty much in her back pocket now. What can she go do in day one when she gets out of here?
Sure. So I two parts to that answer. One is, don't underestimate the base knowledge. So one of the great things about Kings Point is you develop this great base knowledge that you may not think is very specific. I know from my own personal experience, having graduated from Kings Point, love sailing. I was going to sail for a career. I thoroughly enjoyed that. I was frustrated with how much time I wasted in classes that were not involved, that did not involve shipboard engineering and everything like that. And then my career takes a complete change, and now I'm doing mostly theoretical, leading engineers, leading technical teams, and had to go back to a lot of that base knowledge that I thought was quote unquote wasted. So what I would encourage all midshipmen to do is to really kind of like be like a sponge to all information. You don't know when it's going to come, when it's going to benefit you. A lot of the learning process is having that base knowledge where information can stick to. So it may not even be, you may say, hey, I took a electrical engineering course 20 years ago. That's certainly not going to satisfy the demand to be an electrical engineer today. But if you start to develop in that path, you have that base of knowledge that when you start learning about, you say, okay, I know what a capacitor is. I know what a motor is. I know these types of things. And as I'm learning about it, it's sticking to this base knowledge that I can then build on something. So, and then more specifically, or maybe less specifically, would be is more generally is be interested. I would say to most young people, no matter what your situation in life is to not be so absolute, because you don't know where things are going. And that's pretty much, if I could give you one more big takeaway is, you want to be like that center fielder, can go in any direction. Like you don't want to be caught on your heels. You don't want to be charging too early. You want to kind of go where the ball is hit. And you don't want to think that you're no better and you know where things are going. So really what you want to do is just be a sponge to information, learn as much as you can, be curious, be interested, and then be open. Be open to opportunities. If they're career opportunities, really kind of be open to them. Decide what's important to you, but then be a bit of a risk taker in there. And then just not to be too dogmatic in what you think your career will look like, because I would say that if I was to poll most Kings Pointers, they did not at 19, 20, 21 anticipate where they ended up at 50 or 60. So I would say it's just kind of be on the balls of your feet, be flexible, and don't get too stuck in one direction, but definitely be open to learning and experiencing things. And whatever you're doing, be all in on that too. That's the other thing too, is like, don't be too flexible where you're not committed to what you're doing at hand, but really kind of go in all in at what you're doing. And then, when opportunities come, take them.
Okay, before I give out the next question here, I'm going to deploy the poll that the committee had set up. Let me see if I could relaunch it here. I'd like participants to go ahead and answer the questions that will help us develop our program in the future. Then if you want to reach out and give us feedback and information, by all means, I'm going to put my contact information, or I'm going to repost my contact information in the chat room. But the next question actually came from Shelby. She asks about, let's see, where are we? I lost it. Shelby, she wants to know about these technologies. How scaled are they right now? And are they ready to go on to the big ships, such as a container ship that go in a blue water transit? How long until we get there?
It's a great question. It's definitely, that's the question, or the challenge of the industry. So yeah, we see the technology currently exists as the maritime industry does not develop whole cloth technology. If we look at everything that the maritime industry uses, it was developed for another industry and then adopted for the maritime industry, because the maritime industry is not such a large consumer of equipment or such a big player that we dictate to the industry what is technology. So we're really kind of a consumer of technology, and we see this split. It's all the maritime industry, but we're seeing the split between these short distance shipping, these smaller vessels that are taking the route of transportation. So we see electrification coming to cars, to the buses, to all this kind of roadside is utilizing energy storage. And we see in the smaller short distance shipping lends itself very much to this battery technology that's available today. We're seeing every year going forward, there's going to be a couple hundred more vessels with batteries on board built. So that's kind of becoming a standard for that segment. But yes, for the large container ship, obviously a battery is not going to be the technology. So we're going to adopt a different technology. So what we're seeing is the adaptation of these alternative fuels is really kind of moving away from the carbon-based fuel to an alternative fuel, whether that be an engine that runs diesel electric, or whether it be a direct drive engine. That's still to be kind of determined and still being worked out. But the beauty is, within the maritime industry, we don't have to solve that problem so much, because the world will solve that problem. This is not just a maritime problem of finding sustainability technology. This is a global endeavor. So we're seeing all industries kind of looking towards this. That's the same thing with the batteries we're using on the maritime side. They're not produced and manufactured just for the maritime industry. These are being utilized by all industries. So we don't have to really kind of solve that problem. What we have to do is look to see what's happening, look to see what's being adopted, and then marinize that. So making sure it fits towards our applications. There's a lot of work going on, like I said, with all the engine manufacturers, see this coming and are looking towards sizing engines. So eventually you will see probably slow speed, diesel engines that can run on alternative fuels will probably happen. You see the cruise industry, one of the many problems that come out of this COVID situation was cruise industry was doing very well and was looking to reduce its carbon footprint, and was doing a lot of investigation into alternative fuels and large scale, because obviously cruise ships are huge power requirements, very difficult to reduce emissions for. They were developing it. Then COVID happened. A lot of those programs stopped because they were in a survival situation for their companies. And that really kind of hurt the development of these large scale development of green technology. So it'll happen. I think we're going to see, is, like I said, more separation with the market, that there'll be maybe more and similar to a ferry, maybe closer to something that's on the road, and a container ship maybe closer to something else than they were in years in past. That's probably what we're going to see as being different. But yeah, it's definitely a challenge. It's definitely a challenge. But the short distance shipping are the first adopters of this technology, which is also kind of interesting, because the short distance shipping industry segment has kind of been an overlooked segment within our industry. To see them be kind of the first in developing some of this is also kind of inspiring, and kind of a David and Goliath type situation, which I like.
So stepping away from the academic side of the engineering here, a couple questions here that came to me was the licensing. You mentioned about code. The code hasn't caught up to the technology yet. Have you seen or do you know of any evolution in the licensing process that's going to be impacted by this technology, increasing or reducing the manning or the skill certifications required for shipping?
Great question. It's a bit of a bear trap that I would rather avoid. But what I could say is I definitely see requirements changing as technology on board vessels change. Obviously, the goal of the licensing and the goal of the qualification standard is to be able to safely operate and maintain that vessel. And as the technology changes, absolutely, I see requirements changing. We saw that, even with electrical engineering requirements or electricians on board, chief electricians and things like that, requirements changing. So I definitely see that happening, but I can't speak to what how the Coast Guard would see that or any of the regulatory bodies. That's their problem to solve.
The last question that came up was about totally non-engineering, but it was about the supply chain management. Is the battery industry, or I guess what this used to call them SSVs, are they mature enough to not be a limiting factor in the deployment of this technology?
Yeah, so what we have right now, which again is the maritime industry benefiting from other industries, is there's not enough of these first projects to actually keep this whole industry developing and going in these new technologies. We're benefiting from these larger companies that have other resources to develop this technology because they believe in it long term. I can speak to myself and my group. We are not self-sufficient in the new technologies and the hybrid technologies for the amount of effort and the amount of capacity and the amount of income it takes to develop this. But we believe that there will be in the future. So right now, there isn't enough projects to sustain these major companies in the segment, but we do see it coming. It is absolutely coming. There's more and more projects being discussed every year. With that, we'll then develop more and more companies that can provide these types of services, and they don't have to be large, well-financed companies. But we'll start to see, more smaller vendors. The technology will become de-risked in a lot of ways, so that'll also allow to become more standardized. Once the regulatory requirements are there too, it becomes easier to deliver these projects. So we'll start to see more and more players in the segment. But yeah, right now is a kind of limited scope of suppliers that can do some of these things.
Okay. All right, no more questions have come about here. Admiral had to step out because he's got to go make the student paper night over at the Mariner State. So if there's any final comments you'd like to make, by all means. But in the meantime, I do want to say thank you for joining us, and I look forward to working with you in the systems design and maybe with Peter and the shipyard program also. You've got a lot of experience, and I'd like to exploit those resources that you have. The Admiral specifically said, he had to run, and he appreciated your presentation, and he appreciates your support for the Academy. Shelby, Jack, hope I see you over at the Mariner Estates. Get your SDVs on and come enjoy a nice dinner, okay? Go ahead, Pink.
I just wanted to echo to everything Mike says and our Admiral said. Thank you, Ed, for taking time from your busy schedule and enlightening us all with such an important and timely topic, especially delivered during the months of Earth Day 2022. And as the maritime industry strives to go greener, safer, and more efficient. As you mentioned, the fastest changes must happen during the next 10 years so that we can achieve this goal of net zero carbon shipping by 2040. Thank you for sharing your experiences, your insights, and providing your advice as how our students should be well-informed, motivated, and prepared with all this important fundamental knowledge and skills so that they will be able to actively contribute to the changes as leaders and provide solutions to these challenges, especially involving all these complex and advanced designs and operations. And also your impressive, successful career really provide an inspiring example to what a KP graduate is able to achieve that greatly impacts the maritime industry. Thank you for all the time you put in giving us this very educational afternoon. Thank you.
So Ed, the Kings Point family truly appreciates what you've done. We'll be mailing this document to you, if I can just get it to come up. Yeah, maybe I won't be able to get it. There we are. I will be mailing you a certificate of appreciation.
Very nice. Thank you.
Hope for you to join us in future sailings of our Kings Point Industrial Hour. At this time, if Ed has nothing more to say, I would thank everyone for joining us, and I hope to see you at our next KP Industrial Hour.